We had already solved two questions for finite automata divisible by 2 and 3 for unary number system. So here we are having one practice question that you have to solve by yourself. That is, you have to design finite automata for unary number divisible by 4. Now today's question is we are going to design finite automata for binary number system divisible by 2. Now, as this is a binary number system, it will always contain two bits, two their symbols, that is 0 and 1. So we will go and solve it first by mathematical method. So what is that in mathematical method? Is that we have to first find out the binary number system. So for that we would write the decimal number system, and from decimal number to binary number conversion, how it actually look like. So we are having decimal number. We will start with 0. 0 is represented by the symbol 0. Now this 0 can also be represented by 2 zeros. It can be also be represented by 3 zeros and so on. And we are having decimal number 1. For decimal number 1, from the binary bits, that is 0 and 1, 1 can be used for representing number 1. It can be written as a single bit 1, or we can write as 0 1, or we can also write 0 0 1 and so on. The next number comes is number 2. For the conversion from number 2 into binary number system, we are having number 10, or it can be written as 010 or 0010 or 000 and 10. But these two bits will be same everywhere. We can write number of zeros in the beginning, but we cannot add anything at the end. Now we are having number 3. Number 3 can be represented as 13, or it can be written as 011 or 0011 or 0011 and so on. Then the number 4. Number 4 is represented by 100 or 0100 or 0010 and so on. Number 5. Number 5 will be 101. Number 6 will be 110. Number 7 will be 111. Number 8 will be 100. Number 9 is number 9 is 1001. Now the second step in mathematical way is how to divide the number by 2. So we will start with number 0. So number 0, when it is divisible, when it is divided by number 2, remainder will be 0. Now we are having number 1 in binary number system. When it is divided, we are having remainder 1. Now it can be single 0, it can be double 0, it can be triple 0. All are divisible by 2. Number 1 can be written as 1 or 01 or 001 and so on. Now we are having number 2. Number 2 is 11. So number 2, when it is divided by 2, we are having remainder as 0. Then we are having number 3. Number 3, when it is divided by 2, is producing remainder 1. Then we are having number 4. Number 4 is 100. This is number 2. When it is divided by 2, we are having remainder as 0. Now we are having number 5. When number 5 is divided by 2, we are getting remainder as 1. When we are having number 6, it is completely divisible by 2. Then we are having number 7. Number 7, when we are going to divide it by 2, we are getting remainder 1. Then we are having number 8. When we are going to divide it by 2, we are getting remainder 0. Then we are having number 9. When we are going to divide it, we are going to get remainder as 1. So this is your mathematical method. Now we'll go for Thesis method. So the second step is we are going to solve by using the thesis method. For thesis method, what we are going to do, we have to design the solution by using the tape. So this is the tape that we are going to use. Again, I'm repeating, this is the tape which is open from the right hand side. Here we are going to write the current state. On the left hand side, at the bottom of the tape, we are going to write the resultant state, and on the top we are going to write output. Okay, then we will go into designing. So the initial state which is ready for reading the input is called as QS. What is the QS? Is the ready position, ready, or the start state. So that is indicated by QS. Which input is represented, which string is represented is nothing. What is the output generated? Nothing. Now, as we are having binary number system that consists of two bits, zeros and ones, that means there will be two tapes here. So based on the number system, based on the digit, we are going to have that much corresponding number of tapes. So here we are going to have two tapes. So here the QS will be having, we are having two tape having the starting position as QS. So here we can write like that. So here we are having initial position QS. QS is the radio position and is waiting for the next bit to be read. So the next bit, for example, as it is the binary number system can be 0 or 1. So the next bit can be 0. So let us take as 0. So the first bit that we have read is 0. So 0. Now this is the number 0. So what was the case with number 0? Number 0, when it is divided by 2, when it was divided by 2, we got the remainder 0. So here what we are going to write, it is generating remainder 0. So this is the scenario of remainder 0. So this remainder 0, we are giving the state name as Q0. Which string is represented by Q0 is 0, and what was the output generated is remainder 0. Now, so what is the resultant state is Q0, and this is the output. As Q0 satisfies the requirement present in your question. So what is given in the question? The number has to be divisible by 2. So this is it is going to fulfill the requirement. So this Q0 will be our final state. Okay. Now, as we have considered only one bit, now we have to consider the second bit also, which is 1. So the QS, this can also consider, we can read the string which is starting with 1. The first bit will be 1. Here we consider the string whose first bit is 0. Now this is 1. So what was the case? So now this bit is nothing but the string 1. What was the case with the string 1? In string 1, what we have generated? We have generated remainder 1. So we'll give, you write here the condition that is remainder 1. To this remainder 1, we are giving a name, for example, Q1. So what was the output generated by Q1 is remainder 1. Okay, and what is the resultant state is your Q1 state. So what is the Q1? Q1 represents string 1, and what kind of remainder generated, that is 1. Now what we are going to do, we are going to consider this as the current state. So we'll consider Q0 first. We have to consider Q0 also and Q1 because these two are the resultant state, and that has to be considered as the current state. So the Q0 with the current state, so how many tapes will be there? There should be, as there are two input symbols, that is zeros and one. Again, we are going to consider two tapes. And what was the string represented by Q0 is 0. So we will write here. So the Q0 is representing string 0, and now we are waiting for the next bit. So the next bit, as we are having two bits, either 0 and 1, so the next bit can be the next bit. This is your next bit can be 0, and the next bit can be 1. Okay. So when with the current bit 0, the next bit is added, what kind of string is generated? The string generated is 00. What was the case with 00? With the 00 also we are getting remainder 0. So this is your output is generating remainder 0. Which state represent remainder 0? Remainder 0 state is represented by the state Q0. So we will write the resultant state as Q0. So what we are having Q0 on 0 goes to Q0. Now the next bit Q0 with the next bit has 1. The resultant next bit 1 will has created a new string 01. What was the case with 01? So the 01 is nothing but 1 and the 1 is generating the remainder 1. So what will be the remainder here? The remainder will be 1 and what is the state representing remainder 1 is Q1. So we'll write Q1 here. So we had considered Q0 with the next bit 0 and 1 but we have not considered Q1. So we will now consider Q1 state. So now we will consider Q1 state as the resultant state and as we are having two bits 0 and 1 we are going to have two tapes. So here we will consider one tape with Q1 and again one more tape with the Q1. So what was the string that was represented by Q1? Q1 represent string 1. So we will write here. This is 1 and this is again 1. And what we are doing, this is the string. This string is already considered. Now we are waiting for the next bit here. So here we will consider the next bit. The next bit, as we are having binary number system, the next bit can be either 0 and 1. So we will take first 0 here and then we will take 1 here. So if we are going to combine the current bit 0 with the previous bit 1, it will make the number 10. What is number 10? The number 10 is nothing but your number 2. So this is the number 2. What was the output of number 2? Number 2 generate the remainder 0. So it is going to generate remainder 0. And whether we had considered any state who has generated the remainder 0. We had already considered the state whose remainder is 0. That is nothing but the Q0. So no need of generating new state name. Here I can repeat Q0 state because the remainder is same. So this state is nothing but although it is representing string 10 but the output is same 0. That's why I'm having Q0 state here. Now so what we can write? We can write here the Q0 is not only representing string 0, 00, but it's also representing string 10. Okay, now we are having this thing. Previous string Q1 is representing 1 with the next bit as 1 will create a new string as 11. What was the case with the string 11? String 11 is nothing but the number 3. Number 3 when divided by 2 generates the remainder 1. Okay, so whether the condition is already considered here, we have already considered this condition where we are having remainder 1, which was indicated by the state Q1. So no need of generating or creating new state name. So here I can write resultant state as Q1 whose output is 1. So what as the states are repeated here Q1 on 0 is generating Q0 which is already considered, Q1 on 1 generating Q1 state that is already considered. So we will stop generating the tape method. So what we are going to do, we will go for the second step which is nothing but generating a state transition table. So for the state transition tables, what we are going to do, we are going to draw rows and columns. As we are having two bits, that is a binary number system 0 and 1, here we will consider 0 and 1. That means here we are writing inputs. And what we are going to write here, we are going to write states. Okay, so what will the state? The first state that we are considering is your QS state. So as we are writing QS state, where the first state we will write QS state here. We will write QS state. So QS on 0. So the QS state previously nothing was there on 0. Where it is going? It is going to Q0 state. So we'll write the resultant state as Q0. Then QS QS with the next bit S1, where it is going to Q1. So QS on the next bit S1, where it is going to Q1. Now this Q0 will become the resultant state. So we'll write Q0 as Q0 is the final state. That is according to our requirement. So we have to put asterisk. So we'll put asterisk here. Now we have to consider Q0 on 0. So Q0 on 0, Q0 on 0, it is going to Q0 state. So Q0 on 0 goes to Q0 state. Now Q0 on 1, where it is going? Q0 on 1. So this is your current state, Q0 on 1, it is reaching to Q1 state. So we will write here Q1 state. Now, what is the next state that we have to consider? We had to consider Q0, which was the resultant state. Now the time to generate to consider the Q1 state. So now we will consider Q1 state here. We'll write Q1 state. Now Q1 on 0. So where it is going? Q1 on 0. So this is Q1 on 0. It is going to Q0. So Q1 on 0, it is going to Q0. So we'll write here Q1 on 0 goes to Q0. Then we are having Q1 on 1. Q1, this is your Q1. Q1 on 1 goes to Q1 state. So we'll write here. This goes to Q1 state. So whether we had any state which is remaining to consider. So this was the resultant state, consider as a current state. This was the resultant state, again consider as a current state. No state is remaining to be considered. So this will be your end of designing state transition table. Now the time to design state transition diagram. That is your part C of your Thesis method. So we'll design state transition diagram. Okay, so what we are going to do, first of all, we will mark, we will note down the starting table, starting state. So what is the starting state? Is QS is your starting state. How we will mark is we are going to put in a circle, and we are going to mark initial state is always marked by putting an arrow here. Now QS on 0, where it is going? QS on 0 goes to Q0 state. So we'll write Q0 as the state, and Q0 as this is the final state. I will mark it as a double circle. So what is the connectivity from QS to Q0 is by input symbol 0. Now QS on 1, where it is going? It is going to Q1. So there we have to draw Q1 state. So QS on 1, where it is going? It is going to Q1 state. Now next we have to consider the Q0. Q0 on 0, where it is going? Q0 on 0, it is going to Q0. So Q0 on 0, we have to write to a loop because it's going to itself. So on a loop, we have to write the input symbol 0. Then Q0 on 1 goes to Q1. Q0 on 1 goes to Q1. So we have to connect Q0 and Q1 with the input 1. Now Q1 on 0. So this is your Q1 state on 0 goes to Q0. So from Q1, we are going to draw 0. Now Q1 on 1, it is going to itself like this. So this completes our table because we have considered all the states. Now we will take one example and check whether our FA is correct or not. So we will take one example that we have not taken previously. We have stopped creation of your table tape method till number 3. So for suppose we will take number 4. So for taking number 4, we'll take 100. So 100 is number 4. So whether number 4 is divisible by 2. So number 4 is divisible by 2. So the string has to be accepted by your FA. What do you mean by accepted by FA? That it should end with Q0 string. We'll start with QS. Now we'll take QS with 1. That is going QS with 1 is going to Q1. So we'll write QS on 1 goes to Q1 and the remaining string is 0, 0. Now we will write Q1 on 0. Q1 on 0, Q1 on 0. Q1 on 0 goes to Q0. So we'll write Q0. And what is the remaining string? Remaining string will be 0. So we have taken Q1 on 0, resultant state is Q0 and remaining is 0. Now we will write, we will take Q0, which is the remaining string, remaining state with the next bit as 0. So where it is going, Q0 here. Q0 on bit 0 goes to Q0 state. So it is going to Q0 state, which is the final state. That means the FA that we had designed is correct.